Okay, welcome back. What I want to do in this video is go over more examples on solving second order homogeneous differential equations, and then go over more in detail on the Wronskian. And Yeah, that's about it for this video. Um, yeah, let's get started. So, here is an overview for solving second order homogeneous differential equations with constant coefficients. So we went over three cases. The first case is if we have two distinct real roots, if R1 does not equal R2, right? Then your general solution for this equation, right? If y is some function in t, right? Uh, so your general solution for this equation is C1 times e to the R1t plus C2 times e to the R2t, right? So that's the first case. The other case is if we have one repeated real root. So if R1 equals R2, right? Um, um, And then the R1, R2 terms, this comes from solving the characteristic equation, right? This comes from solving the characteristic equation, AR squared plus BR plus C is 0, right? And so if you have one repeated real root for the characteristic equation, then your general solution y of t is equal to C1 times e to the RT plus C2 times t times e to the RT. Okay, so make sure you do not forget to multiply this, the second term by t. Okay, this has to do with the fact that we have an independent set of solutions, right? Independent set of solutions, which the Wronskian computes for, right? The other case is if we have two complex distinct roots, right? So if R is equal to alpha plus I beta, right? And so then y of t is equal to C1 times e to the alpha t times cosine beta t plus C2 times e to the alpha t times sine of beta t. So those are your general solutions for the homogeneous second order ODE, right? So let's, oh, and then one more thing I want to go over is the Wronskian, the Wronskian. So to show if two functions, y1 and y2 of t, are independent set of solutions, you need to show that the determinant of this matrix is not 0, right? So the Wronskian of y1 times y2, okay, this equals to y1 of t times y2 prime of t minus y2 of t times y1 prime of t. Okay, that's the Wronskian, right? And it's a function in t, right? So that's the definition. Okay, and let's go over an example on showing if two functions are linearly independent or not, right? So if we have y1 of t as t times e to the 2t, and then y2 of t is e to the 2t, we have to show if they're linearly independent, right? So the Wronskian, y1, y2, well, it equals to the determinant of this matrix, right? y1 of t is just t times e to the 2t. Y2 of t, this spot would be e to the 2t. Okay, this spot down here, this would be y1 prime of t. So we have to use the product rule. So we'll have e to the 2t plus 2 times t. e to the 2t. So that's the product rule. And then this spot right here would be 2 times e to the 2t. Okay. And so this quantity would equal to, so this quantity would equal to 2 times t e to the 4t minus, so we'll have e to the 4t, and then that would be a minus. That would be a minus 2t e to the 4t. Okay, so these quantities will cancel, and we'll have a minus e to the 4t. Now, this function is never zero, right? It's never zero. So, we have to show that this Wronskian is not zero for all t on the entire real line in this case, right? Since the exponential function is never zero, we can say that y1 of t and y2 of t are in fact independent. Okay, they're independent set of solutions. All right, so that's just a quick example on showing the Wronskian, right? And so let's go over some examples on solving second order differential equations. Okay, so we have this example. And the first thing we want to do is to transform this differential equation into the characteristic equation, right? So the characteristic equation, right? So that means transforming the function y and its derivatives into powers of r. Okay, powers of r. So our function y will correspond to a constant 1, right? Y prime corresponds to r. Y double prime corresponds to r squared. Y triple prime corresponds to r cubed, and so on, right? So in this example, the differential equation will become r squared plus 2r plus 2 is 0. Okay? So hopefully that made sense. Now, since 2 is a prime number, right, since 2 is a prime number, well, there is no way to figure out a sum that equals 2 by using 1 and 2 as its factors. So we're going to use the quadratic formula, but that's all right. So r is equal to -2 plus or minus the square root of 2 squared minus 4 times 1 times 2 over 2 times 1, right? So that's the quadratic formula. So r is equal to -2 plus or minus, we'll have the square root of 4 minus 8, which is the square root minus 4 over 2. And so r is equal to -1 plus or minus, in this case, we'll have a 2i, so -1 plus or minus I. Okay, so we have two complex roots. Two complex roots. So what that means is, let me write out, yeah, this is right here. So the general solution y of t, okay, so this would equal to c1. So the alpha here is -1, and then the beta is 1. So it'll be c1 times e to the minus t times cosine t plus c2 times e to the minus t times sine t. Okay. All right. Now, what we need to do next is initialize the initial conditions to solve for C1 and C2. So first of all, when t is 0, we'll have a C1 here plus C2 times e to the 0, which is 1, times sine of 0, which is 0. So we'll have a C1 plus 0 equals 2. Okay. And what's going to be the challenge here is solving for the other constant. Okay, so that will involve taking the derivative of the general solution, right? Taking the derivative of this function. So we know that y prime of t, let me actually, I need some more room in order to write this out. So, okay. Oh, Jesus. All right. I appreciate the patience. So anyway, so now what we have to do is differentiate the general solution. Okay, so we'll have C1 times, so this will be the product rule. So we'll have a minus sine t times e to the minus t, and then we will have a minus e to the minus t times cosine t. Okay, plus C2 times another product rule. So we'll have e to the minus t times cosine t, and then we'll have a minus e to the minus t times sine t. Okay. Now we can evaluate the derivative at 0. So when t is 0, we will have, so C1 times this quantity here is 0. That is a minus 1. So we'll have a minus 1 plus C2 times, this will be this e to the 0, which is 1. So this will be a 1 minus 0. That would be equal to 1. All right. So what that means is, so we know that C1 is 2, and we also know that minus C1 plus C2 is equal to 1. Okay. So that would conclude that C2 is 3. Okay. So that C2 is 3. And so therefore, the particular solution, YT, so this would equal to, so that, oh, Jesus. So that would equal to 2 times e to the minus t cosine t plus 3 e to the minus t times sine t. Okay. All right. And just got to double check to see the solution was right. And C2 and 3. Okay, great. So there is that example. Let's go on to another example. Okay. Here's another one. I want you to try to work on this on your own. Okay. So I want you to solve this initial value problem here. Okay. And if you solved it, great, because I'm going to go over it right now. So first things first. We need to write out the characteristic equation. Characteristic equation. So this would correspond to r squared minus 4 times r plus 2 is 0, right? And then what we need to do is solve for r, right? So r is equal to, in this case, 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2 over 2 times 1, right? By the quadratic formula. And so this equals to 4 plus or minus. So we'll have a 16 minus 8. 8 over 2. And so this would equal to 4 plus or minus 2 root 2 over 2. And so we'll have that r is equal to 2 plus or minus root 2. Notice here, these are two distinct real roots. They're real roots, okay? So the general solution, so let me write out the general solution up here. So it looks like this form. So C1 times e to the 2 plus root 2 times t plus C2 times e to the 2 minus root 2 times t. So that's the general solution, right? Okay. So yeah, make sure we jot those down. And so the next phase we need to do is solve for the constants, C1 and C2. Okay. C1 and C2. And that will come from by using the initial conditions. Okay. So when t is 0, we'll have that y of 0 is equal to C1 plus C2. And that has to equal 0. So this is our first equation. The next initial condition will come from by differentiating the general solution y of t. So that would be equal to, so the derivative of t, y, this is 2 plus root 2 times c1 times e to the 2 plus root 2 times t plus 2 minus root 2 times c2 times e to the 2 minus root 2 times t. Right? Okay. And so when t is 0, what we will get is, so we'll have 2 plus root 2 times c1 plus 2 minus root 2 c2 is equal to 1. So this is the other equation that we're going to use. All right. So by this equation here, we know that C2 equals to minus C1. And from this equation, we know that 2 plus root 2 times C1 plus 2 minus root 2 times minus C1 equals 1. Okay, so now terms will cancel. We'll have a 2 times C1 plus root 2 times C1 here. And then we will have a minus 2C2 and then plus root 2C1 here as well. And that has to equal 1. Okay, these 2's will cancel. And we will get 2 times root 2 times C1 equals 1. And so that would conclude that C1 is equal to 1 over 2 root 2. And since C2 is equal to minus C1, we'll have C2 is negative 1 over 2 root 2. Okay? And so the particular solution will be, so C1 is 1 over 2 root 2. And this right here, plus a negatives, this will be a minus 1 over 2 root 2. Okay. So that, folks, is the particular solution. So I hope that made sense. Okay. Let's do one more example. One more example. Okay. So in this problem, I want you to solve for the following general solution for this differential equation. Okay. So if you have it down, great, because I'm going to explain it now. So the left-hand side, you want to write out the characteristic equation. Characteristic equation. Okay, characteristic equation. So this will correspond to r cubed. Oh my goodness gracious. So that would equal to r cubed minus 4r squared plus 7 times r minus 6 is 0, right? That's the characteristic equation. So now from here, you want to solve for r. And you might be stuck at this point. That's fine. But we're going to use a property called synthetic division in algebra, right? To figure out the roots of a polynomial, we're going to use synthetic division. Okay, and then we're going to also use the rational zeros theorem. To do this, right? Rational zeros theorem. Now, the rational zeros theorem, right? So the factors of a polynomial could possibly be plus or minus the factors of the constant in your polynomial divided by the factors of the leading coefficient. So in a nutshell, that is the rational zeros theorem, right? So it's plus or minus the different factors of the rational numbers of the factors of a constant over the factors of the leading coefficient. So the leading coefficient here is 1 and the constant here is 6, right? So in this case, this would be plus or minus the factors of 6, 1, 2, 3, 6 over 1, right? Which is plus or minus 1, 2, 3, 6. So these possible numbers here are factors for this quadratic equation, right? And so you want to try to use synthetic division to solve for the roots, but if you use r equals 2, that would do it, right? So I'll show you how to do that. Okay, so I'll show you how to do that. So synthetic division. You want to draw on a plate like this, a slate like this. You want to draw in, or I should say, fill in this box right here with the factor in question. So in this case, we're showing that r equals 2 is a solution for this equation here. So on the first row here, you're going to fill out the coefficients of the polynomial in R. So, in that case, in this case, it would be 1 minus 4, and then 7, and then a minus 6. Okay. So here's what you do. First, we bring down the first number, 1. To get this number, we multiply by 2, okay, which is a 2. And then to get this number, we add the numbers from top to bottom. So in this case, -4 plus 2 is a -2, okay? And then to get from this, so to get this number here, we multiply by 2, which is a -4, okay? And then to get to this number, we add the numbers from top to bottom. So 7 minus 4, which is 3. And then to get to this number here, we multiply by 2, which is a 6. And then to get to this number, we add the numbers from top to bottom, which is 0. If this number here is a 0, we can say that 2 is a 0. And so that would correspond to saying that the quantity r minus 2 is a factor of the the polynomial r cubed minus 4r squared plus 7r minus 6. Okay. And what's also great about this method is these numbers down here, this will correspond to a degree 2 polynomial. Okay. So in particular, they are coefficients for a degree 2 polynomial. All right. So another way to write out this polynomial on the left is we can say r minus 2 times r squared minus 2r plus 3. And that has to equal 0. Okay. If you factor out the left-hand side here, you should get back to the original polynomial you started with, right? So it's pretty nice about synthetic division, right? So now we know that since this product here has to equal 0, r minus 2 equals 0, or r squared minus 2r plus 3 is 0, right? So 1, 0 is at r equals 2, and the other 0, the other 2 zeros would come from this equation, right? And so we need to find two numbers that multiply to be 3 and they add to be minus 2. So in that case, let's see. Do we have such numbers? I don't think so. Let's see. Yeah, we're gonna have to use a quadratic formula for this equation here. If we're a minus 3, then that would work. If that were a minus 3, that would work. But we have a plus 3, so we have to use a quadratic formula, but that's okay. So r is equal to 2 plus or minus the square root of minus 2 squared minus 4 times 1 times 3 over 2. Okay. And so all right, I'm going to erase this. Clean this up a little bit. Okay. So what we'll have here is r is equal to 2 plus or minus. So we'll have a 4 minus 12, which is minus 8 over 2. So we have r equals 2 here, and then r is equal to 2 plus or minus 2 root 2 over 2. This is I here. And then r is equal to 1 plus or minus root 2 times I. So we have 3 roots. Root 2i, and r is equal to 1 minus root 2 times I. Okay, so the general solution So the general solution, y of t, is equal to c1 times e to the 2t plus c2 times e to the t times cosine of root 2t plus c3 times e to the t times sine of root 2 times t. Okay, so that's your general solution. So hopefully that helped. And then here's some problems for you to check comprehension. So, yeah, so these will involve the solving second order differential equations in the homogeneous case, right? So if you have questions, let me know. Hope you enjoyed this, and I'll see you next time. Take care.